How terrifying is absolute zero? Why can the highest temperature in the universe reach a staggering 140 quintillion degrees Celsius, while the lowest possible temperature is only minus 273.15 degrees Celsius? First, we must understand what absolute zero actually is. In 1802, French chemist Louis-Joseph Gay-Lussac conducted an experiment based on the thermal expansion of gases. He first prepared a graduated glass container with a movable piston that fit tightly. Then he expelled all the air inside the container, injected nitrogen gas through a rubber tube, sealed it, and used a thermometer to record the room temperature. When the temperature was 24.83 degrees Celsius, the gas volume inside the container measured 84 milliliters. Next, he placed the container into a large bucket of water and added ice to cool it down to 0 degrees Celsius. The reading showed that the gas volume decreased to 77 milliliters. After that, he replaced the cold water with boiling water. When the temperature rose to 99.33 degrees Celsius, the gas volume expanded to 105 milliliters. As the temperature dropped again, the gas volume gradually decreased. Gay-Lussac then plotted a graph with temperature on the x-axis and gas volume on the y-axis. The data points revealed a linear relationship between temperature and volume. When he extrapolated the line beyond the measured range, it intersected the x-axis at minus 273.15 degrees Celsius, the point at which gas volume would theoretically reach zero. Since the volume of a gas cannot be less than zero, this implied that no temperature can exist below minus 273.15 degrees Celsius. Even when different gases were tested, the results remained consistent. Temperature and volume were always proportional. As temperature approaches absolute zero, the motion of particles slows dramatically until they are almost completely still. At this point, everything would freeze. Even light could no longer behave normally. If a person were somehow to touch an object at absolute zero, they might not feel pain immediately, but the intense cold would rapidly penetrate the skin, destroying nerve endings and muscle tissue. Unfortunately, even today, scientists have never been able to achieve minus 273.15 degrees Celsius in a controlled laboratory setting. However, about 5,000 light-years from Earth, in the direction of the constellation Centaurus, there exists a planetary nebula with a temperature of minus 272.15 degrees Celsius, just 1 degree above absolute zero. It is currently the coldest known place in the universe. Many scientists believe that the end of the universe will resemble what is known as the heat death. The mysterious force of dark energy may drive the universe toward a future of cooling and stagnation, where all thermodynamic processes cease. Eventually, the universe will reach a state without free energy, where physical laws collapse and no form of life can exist. After approximately 10 superscript 1 years, even black holes will have completely evaporated. At that moment, the universe will enter an eternal, unchanging state for the first time since its birth. Time itself will lose all meaning, entropy will stop increasing, and the cosmos will reach the end of disorder, a frozen silence where nothing will ever happen again, forever.